Is about polar coordinates and derivatives, and this is a little introduction to graphing things in polar coordinates. So in a rectangular coordinate system, you basically have your x and y axis, and x is moving horizontally and y is vertically. Well, with a lot of times, a lot of expressions, or well, these would be usually things that are not functions, but using polar coordinates is actually an easier way to represent those graphs. So in your polar system, you have, instead of the origin, we call it the pole, and what we would normally think of as kind of the positive x-axis is now the polar axis. And so basically the way we're going to graph this is we're going to graph points that are of the form r theta. Now, even though theta is second, it's actually the independent variable. So it's actually what we do first. So this point right here is what is graphed on that grid up there. And so to graph that, basically, here's what you do. You start at the polar axis and you turn pi over 4. So you visualize a ray going through pi over 4. And then the circles are there to show you the units that you would count on any ray that you've extended. And so we count out 4 units, and that's why the point lands there. Now, if we want to talk about other ways to name that point, then we've got to think about the fact that we've got many different ways to name pi over 4. So instead of like in a rectangular coordinate system, we have one way to name everything. Here we're going to have many ways to name this point. Matter of fact, infinitely many. So for example, what if I said 4 and then 9 pi over 4? Well, 9 pi over 4 would mean start at 0, go all the way around 2 pi, and go up another pi over 4, and you land exactly right where we are right there. So anything that counts that direction, then that will work. And we can also do negative. So if we wanted to do negative 4, we could do 5 pi over 4. So 5 pi over 4 would be over here. So you would have this ray going through 5 pi over 4. And then negative 4 means to go back up the other direction, which is this way, and you end up right on that point again. So there's infinitely many ways for us to name these points, and so that's just something that you have to consider, and that's just what makes it a little bit different when we have to find intersections and things. So be sure you have your calculator. If you don't have your calculator, hit pause and get your calculator, because you're going to want to graph some things here. So let me get to the next page. So go ahead and turn over your notes to the next page. And we're going to talk about looking at some graphs. Now this is, you put your calculator, it's not really in polar mode, so I'm going to show you how to graph these. Now I'm only going to graph a couple of them, and then you need to graph more of them if you want, so you can see the connection here, but we'll be able to see the connection pretty quickly. So here we have, on the calculator, we want to graph r cosine theta. So on your calculator, go to a calculator page, not the scratch pad. Go to a regular calculator page. On the calculator page, then you want to enter this graph, but of course this says f1 of x. So we don't want to do that. We want to put it in a different system. So remember, when you need to figure out something the calculator does, a great thing to do is hit menu. Well, look at the choices there, and we can see graph, entry, or edit. Well, that makes a lot of sense here because we want to enter the graph in a different way. And so we can see there under graph, entry, or edit, number 4 is polar. So now instead of saying f1 equals, it says r1 of theta equals. And then it's telling me that theta is counting from 0 to 6.28, which is 0 to 2 pi. And the theta step is by 0.13, and that's just saying that that's how many points it's going to find the values of and then plot, and it's just going to do it one time around the unit circle basically. There will be times where we might need it to do more than that. So let's start with graphing. Let's just graph the two that are right beside the calculator here, 2 cosine theta and 2 sine theta. So we'll do 2 cosine, and then the theta button is down where the pi button is, and you get the little pop-up menu, and then you choose theta. And then we press enter, and we see that we have a circle. And we have a circle here that is it is tangent, or it goes through the pole, and then it is symmetric around the x-axis. So you can draw that if you want on your paper here. So you would just draw your circle just like this. And that's a really bad drawing, but that's what it would look like roughly. Okay, so then let's do 2 sine theta. And let's just go ahead and do it right here on the same grid. So hit tab. That way we don't have to select polar again. So let's do 2 sine theta. And remember, again, theta is there where the pi is. And then hit enter. Well, we got a circle that is, again, goes through the pole, but this time it's symmetric about the y-axis. Well, with the calculator, you could go ahead and type in a whole bunch of these if you want. So type in various ones, and you will see, and you should even be able to tell this quick, that this, even if you just did a couple, you'll find out this number right here is the diameter, not the radius. So notice that on the blue graph there, you have a diameter of 2. That's where the 2 comes from. So the radius would be 1, and it's cosine theta, and it happens to be symmetric about the x-axis. When we had 2 sine theta, 2 again is the diameter, and then sine theta is symmetric about the y-axis. Well, that shouldn't be surprising, because sine is your y value on your unit circle, and cosine's x. So if we were just to go ahead, and you can just type in some more, if I did say 4 cosine theta and did that, I would see a circle that has a diameter of 4 and still symmetric about the x. So basically what we notice is, to graph a circle that is not centered at 0, 0, if it's a number and then cosine theta, it's symmetric about the x-axis. If it's a number, sine theta, symmetric about the y. Now, even on this same graph, let me graph real quick something easy to see. Let's just graph r equals 4. Well, there we get a circle, and now we have a radius of 4, and it is centered at 0, 0. So there's all the different ways that you can get a circle on the graph, at least a circle that goes through the pole or centered at the pole. So that's one type of graph that we need to be able to do. So let's get a new graph page open, and let's look at some of these down below. So if we go and move this, we want to look at these graphs to see what they look like. So we're going to graph, let's go ahead and do 2 plus 2 cosine theta. So I've got to go to menu, graph edit, polar again. And I want to do 2 plus 2 cosine theta and hit enter. And I got what is called a cardioid, and it's like a little heart shape. So you can draw that on your grid here, and you know, again, the best you can. Whoops, that one really starts to look like a heart there. It's supposed to be a little more rounded than that, but there's your graph. So let's see what happens. And again, notice the symmetry around the x-axis. So you could make a guess, and you should try on your own all the sine graphs and see if you notice anything. So that's what 2 plus 2 cosine theta looks like. So now let's try 1 plus 2 cosine theta. I'm going to go ahead and do it on the same graph. It'll be a little hard to see, so if it's too hard to see for you on your own calculator, then go ahead and do it on another page. So I'm going to do 1 plus 2 cosine theta. Okay, so this time my graph is kind of like that graph, only it has a little loop on the inside. And so it is a little bit different. We have it's called a limacone with an inner loop here. So, and it didn't go back quite as far. And that's a really bad drawing. My board isn't very oriented, but you have a limacone, it has an inner loop. So this time you have a little loop. Well, that's where it gets a little difficult if you're graphing these by hand because you have that inner loop. So you're going to have, you can probably visualize this here at, say, pi over 4. Clearly, I've got two different values that I'm getting at pi over 4. Well, we can't really have two values, so probably one is positive and one is actually negative coming from the other way. Okay, so let's look at the last graph, which is 2 plus cosine theta. So I'm going to go ahead and graph it on here, and hopefully we can see it pretty well. Nice thing is we have the different colors, so that definitely helps. So let me move the equations here a little bit. So 2 plus cosine theta is in kind of a darker red, probably really hard to see on there, but basically it is a kind of flattened out, so it's kind of that cardioid shape, but right here it's kind of flat, and then it goes out and makes your shape. Okay, so it's kind of called, it's like flattened out on this side, so it's not completely round. And it's not really a straight line flat, but it is pretty flat over there. And so those are basically your three types of graphs that you would get. Now, I bet you can guess what would happen if you did sine instead of cosine. And so what we need to notice about this is, how do you know if it has an inner loop or anything? And so basically here is your criteria. If you have r equals a plus b cosine theta. Well, here we had a and b equal. So if a equals b, you're going to get your heart shape. Here we have a and b, and we have a is less than b, and we got an inner loop. And then here we have, this is a 1, so here we have a greater than b, and you had that one that is kind of flat. Okay, now I'm going to give you a handout that has that sort of organized a little bit better, so that you know what those are actually called, and it kind of writes that for you. Okay, so let's go ahead and look at what the graphs look like on the next page, just to see what we're going to get, because this is the last type of graph that we really need to know. So we're going to go ahead and open a new page, and again go to menu and then change it to polar. And so let's start with 3 cosine 3 theta. And if you remember from doing these before in pre-calculus, you might remember what it looks like. And there we go, we get a rose curve. Okay, so I'm going to go ahead and skip to doing one of the ones on the bottom, and like 3 cosine of 2 theta, and let's see the difference. So this was 3 cosine 3 theta. So let's go ahead and do 3 cosine of 2 theta, and see if even from 2 examples you can kind of figure out what's happening. So they're both what we call rose curves, or flowers. So they have kind of petals. And so when we had 3 theta inside, we got 3 petals. When we had 2 theta inside, we got 4. And in fact, that is what will happen. You will generalize that to, if it's even, you get double the number of petals, and if it's odd, you get the same number of petals. And so on the next video, we'll talk more about that, and then how to combine them, and back and forth. So change polar to rectangular and back and forth, because sometimes that's necessary.